started, and if people come in later, they come in later. Okay, so pleased to introduce our next speaker, Marta Nieto Cayala from Uber, who will introduce herself in more detail and who'll be sharing Uber's really exciting journey around deploying large language models for quality estimation. So off to you.
Thank you so much, Olga, and thank you everyone for the Gala organization for having me here. And good afternoon, and thank you to you too. Like, I know this is like the very last session before the keynote. You may think you might have heard everything. It's just after lunch, so bear with me, please. My name is Marta Nieto Cayuela, and I am a localization experience program manager at Uber. If you came expecting meeting James, apologies, he could not make it to be here today, but any questions you have for him, I will be happy to take. So at Uber, apart from managing the language quality for Europe, I'm also responsible to the machine translation large language model quality program, and that's what I would like to share with you today. So, quick show of hands. I guess you know what this is. This is a scorecard. A hands up, how many of you have spent an afternoon filling out one of this, or auditing, or reviewing? So feel your pain, been there, done that, and I mean, once upon a time, I think we all had a dream, which was as, okay, when this is gonna change, when we are going to be able to automate error categorization. So this is no longer a dream, this is our reality, and that's what I would like to show you today, which was the pilot. We ran like some internal experimentation at Uber to try to do the automate categorization using our very own quality model. So before that, I would like to circle back and explain a little bit of the context of the globalization team at Uber, which is that we have a vision, which is that provide a magical experience for our users. But we have a mission, which is that make Uber feel local, everyone, everywhere. What's AI doing for us? We are able to ensure that this is happening at scale. So we have been hearing a lot about AI, but today I want to show like an application about how AI can help us optimize language quality management processes. So, the role of large language models at Uber. We are early adopters. We are very lucky being a tech company and having scale solutions within the same globalization organization. That's allowing us to do this internal experimentation I was talking about. That's where the magic happens. Actually, we are so lucky that we have NLP specialists within our very own team that are able to work directly with us. This is providing us to gain competitive advantages. And the fact that we are early adopters is giving us room for not only for the experimentation, but to complete the feedback loop. We are able to gather this internal feedback to ensure that when we run it in production, it actually works or it results as we expected. So, of course, like if we are talking about LLMs and what we are using them for, we need to talk about how LLMs facilitate the content generation and the cleanup of this actual content that we are going to be using for the data compilation. Multilingual support is one of the other cases we have, same as for summarization and chatbots, because in the content realm that we have nowadays, in which multilingual is queen or king, we need to be on top. So LLMs are game changers, but they are changing just like the approach in which our role is being seen in the industry. At the side, you can see some of the use cases that we are having at the moment. I think that some of these will not be new for you. You may all be doing terminology extraction through LLMs, for example, TM cleanup, but the one I would like to focus is the last one, which is about using LLMs for LQA and MQA. So, this is my favorite topic. So, let's talk quality. When we have a globalization team, we need to have a strategy for quality. And when we envision quality, we can have Quality upstream, that's going to be the detection of issues. We can be talking about, for example, source text analysis, creation of style guides, creation of databases. Then also we have quality downstream. That's going to be about fixing the issues, right? That's going to be, for example, about doing LQAs, doing testing, auditing the content. And that's going to be our focus today, quality evaluation. You saw the scorecard. So if you have been doing those for a while, there's not much that I'm going to say that you don't know yet. So try to put together a little bit of a SWOT. We need to evaluate the content we do. We want to have a pulse check. We want to try to understand how we are doing. So that's going to keep on happening. We won't be stopping from doing that. We want to perform. We want to monitor our performance. Those that provide services to enterprises, we need to collect data to actually put together the strategies and the action plans. We want to complete the feedback loop, but it's manual. It takes time, takes effort. It's a cost. We are talking about someone to be able to produce a scorecard or some quality evaluation. Productivity metrics are about 800 or 1,000 words per hour. So imagine auditing a great sample of content. That's not possible. With this scalability that automating LQL can bring to us, we are able to audit a bigger sample size. We are able to do this not downstream but upstream because this could be happening before delivery. So also something else, which is like the room for subjectivity. We, as human beings, evaluating content, how many preferential or personal changes we see. We are able to take those, or at least to reduce the amount of subjectivity by using the automation. So, a lot of room for improvement, and that's why we wanted to run this internal pilot. And this is it. So, what you can see on the screen, this has been our internal experimentation on applying LLM through language quality evaluation. This is based on Gemba, or Gemba. We can discuss what would be the better pronunciation for that. Gemba stands for GPT Estimation Metric-Based Assessment, developed by Microsoft. And it's the metric that actually Christian Federman put together to evaluate each segment in isolation to see the accuracy, let me circle back. To evaluate each segment and get a score compared with another score, right? So we used Gemba through GPT, and this is what we got. The idea was to produce not only a score, but the actual error categorization. The good thing about Gemba is that not only you can get the final punctuation or final result, but you can get your customized quality model within it. And this is actually what you can see in the screen is what we got in return. So we have the sentence, we have a score. I know this does not correspond to MQM, which would be like the standard way you would apply it, but it could be applied. And then we have 3 columns with the 3 different severities. You will see that we have attributes for each of those. We have tags. And you will see that if the LLM did not identify any error, we have the no error tag. But when it did, we actually have the categorization from the quality model that we decided to use in place. And we have the explanation and the isolation of the error. Of course, when we were running this experiment, we wanted to have the human assessment part. We actually wanted to evaluate what our human reviewers were thinking about correlating if this was actually true, if the fact was accurate or not. The very initial was a 60% of accuracy. So we are getting there. I know that there are other research that have shown 60-80% of accuracy. And you may think, well, there's still a way to go. Absolutely, yes. But why this is going to be useful? To triage. We are going to be able to focus on larger sample sizes and to isolate the room for improvement we have. That means that if I see, or you may be able to see that some segments may be scoring, in fact, below the thresholds using, for example, another score like MTQE, you may like to take those, run the auto MQA, identify the areas of improvement, and try to fix those first. So then in yellow, you can actually see what was like the human in the loop part of it. This seems easy, but then how do you do that? What's the takeaway? What do you need from a technical perspective to actually be able to run it? So these are a little bit of the technical requirements we had to put together. Of course, we need a high-performance GPU. Because you may actually need to run it in several machines. You may need to have like multiple GPUs in several machines to be able to have the best computational resource ever. Then data storage. So high bandwidth storage solutions are required as well for not only for read and write capabilities, but also to query and to retrieve the data. Selecting and collecting the training data, and not only collecting it, but cleaning it is an essential part of the entire process. So you need to ensure that you collect high quality data from your translation memories, from your terminology database, from all your legacy repositories you may have, and then ensure that you have the right software to pre-process that data. I'm talking about duplicates, about noise, very old content. Those are things you may like to leave out. Also, we might be talking later about which kind of content type you may like to be having in or out. Then the software stack. In our case here, we are talking about TensorFlow, PTouch, Hugging Face transformers, of course. You may know those. Then networking. We need high-speed networking to be able to support the amount of data we will be transferring. Then, of course, development tools. That's where the magic happens. And humans, we are still in the loop very much, not just by putting this together, but then in participating in the assessment. And then evaluation metrics. We need to understand how we are performing, no matter which one you may choose, but they need to be in the loop. And something that has been said over and over these days is that there is no one size fits all, so you may need to pick one that works better for you. So a little bit sneak peek of the workflow we put together. This diagram outlines the process that we use to apply the LLM into the auto MQM, or the automatic language quality evaluation. This process is for developing, fine-tuning, evaluating, and implementing. And you will see 4 different colors. First, we have in yellow, that's data selection, and that's the very initial. So data selection, collection, preparation, and cleaning. That's where we start. Then if we move downwards, that's orange, or that should be orange. And that's the model architecture, in which we include model selection, pre-train, fine-tuning. Then, of course, we move to purple at the very end, which is about the data and the document storage. You will put here all the different data sources that you may like to include. Something that it's not, and that has been also mentioned, it's the vector databases. They integrate and they need to be in the workflow because they intersect in the representation of data, and they are complementary to each other to optimize the performance and the scalability of the model. Then green, that's the prompt. We are building the prompt, and we are refining the prompt, and we are doing that to multi-shot reinforcement prompting. And last but not least, again, purple, that's where we are sending the content for translation, and we are getting the expected output from the LLM. Of course, when you embark in such a journey, you will have a lot of challenges, a lot of obstacles. But I would like to change that premise, It's not about obstacles, they are opportunities. We are talking here about pilots and internal experimentation. And these days I was reading something in LinkedIn, maybe from some of you, that it was about taking risks. And taking risks, that's about making errors. And you need those to actually get your lessons learned and your area of improvement. Quality is about continuous improvement, and with large language models, we are learning that everything on the day is about continuously improve. So we are taking challenge as opportunities for further learning. First of all, training data set size. Imagine you have a library with everything that has been written ever. This is the size of the knowledge we are talking about. That's a lot to process. So we need to understand what kind of data we want to incorporate, because that also is going to affect how much and how we want to clean it. It's not going to be the same approach if we are talking about low resource languages, or if we are talking about APAC languages in which their tokenization is different. So that also affects not only the amount of data, but also how we are cleaning it. Then, of course, content type selection. Something that we face is that at Uber, we manage support content, software content, so the UI of our app, marketing content, legal content. They are all a different vernacular. They don't speak the same. They might have like different tone of voice because their scope is different. So that also influences how we want to put this together. Another challenge we were facing, we had tons of data of the audits that we were performing. So we were using those, but then we questioned ourselves how objective those are. If there's been a human behind those, do we know that they are 100% objective? So that's also actually affecting the output. And of course, latency, security, and GPU. And those are changing. I mean, you know, like the latencies of the LLMs now are not what we would expect. Our initial pilots, like they were taking hours. And by hours, I don't mean a couple, multiple hours to actually get the expected results. But this is evolving. I mean, the latest NVIDIA, Blackwell from NVIDIA, which is just out, it's like 4 times faster than the previous version. So this is going fast, and I hope that latency improves as well as we move forward. We faced all this, which gave us a lot of food for thought, but I also want to share with you the wins. So if we don't take into account the latency, time and cost efficiencies were very clear. Also because we were able to understand better how we were performing almost immediately. It was like instant knowledge that we were able to collect and process. So of course, like we have the reduced human dependencies as well, and not talking about eliminating them fully from the loop, but optimizing the way that they were dedicating their time and triage, for example, and to narrow in the areas of focus. Customizable quality models. We all have different quality models. From Lisa, SAJ 2450, the latest ISO 5060 if you want. We can have this quality evaluation through the AutoMQM with your preferred model. In our case, we were using our own, which is based on MQM. Then, of course, larger audit samples and data collection. This was no longer about doing a pulse check, but being able to understand the full performance of the content. Instant productivity that we talk, and of course, like proactivity in the way we were looking into the strategy. We were no longer working downstream, but upstream. But this pilot didn't cover everything, and we are talking about the speed that this is going. So while we were completing it, there were already areas that we knew we had to tackle at a later stage. So evaluation consistency. If you run the AutoMQL, AutoLQE today, and you did tomorrow, you may get different outputs. or you may get different outputs within the same document. So that's something that we will never need to work on. The implementation of RAG. RAG allows to incorporate in the workflow the check for a parallel document, an immediate check to the parallel document. So if you have new scorecards, if you have a new or a specific quality model that you would like to use, those are the way to go. Also, as well, multi-shot reinforcement, something that we will be looking at, and of course, evaluating low-resource languages. We serve more than 55 languages, so we can not only have into account the first or the most important, those ones that we know that are the long tail, but also everything else. So this was about the pilot we did. And you may think, okay, and what now? What are you doing? So we want to show you a little bit more of what comes next. Okay, so what comes next? How many of you have heard about semantic similarity? Okay, great. Would you like to come here and explain? Okay, I'll take it. So semantic similarity, this similarity analysis is about rating the differences in meaning, accuracy, syntax compared to the original translation. We have different use cases. We have sentiment analysis. We have source text analysis, but this is not what you have on the screen. This is a completely different. So let me explain it to you. What we have represented here, so the second and the third column, right? Those are two different translations for the same source content. And then what we have been doing, like all these numbers, are about the semantic, the syntactic, the substring, the subsequence, the editing distance, and the length. What I would like you to look is the blue cell. That's a semantic similarity. What does that mean? It means that the lower the number, the less similarity there is between the two translations that we presented. So for example, if we are looking at the second example, that 90%, it shows us that it could have been potentially copied from machine work. This is one case. Now, let me show you a different case. So you can see an example about a message from a male driver to a female rider through the app content. We are using the similarity analysis to identify non-acceptable behaviors as well. Kind of profanity check. So you can see this is one of the examples we have, but let me show you a couple of more between. So this would be offensive, of course. And then we have a couple of extra. So you can see the list of actual terminology that we were trying to identify and the similarities that we were getting for the confidence scores. Something else as well, same part of the analysis. And that has been our focus so far. So I don't know if you may have any questions. Okay, we'll be happy to take it. Thank you so much for your attention. So now let's move to the questions.
Marta, thanks so much. And